Okay, find the general antiderivative for each functions. So to find the antiderivative, we use this symbol, right? It's a summation, right? It's an S, but you put it long. It's an integration symbol. Right? Second square 2x minus sine 3x plus 5. Right. So this part, it just asks you what function's derivative is this. Right. Notice that tangent 2x, the derivative is second. Right, let's write it here. Right, tangent 2x, its derivative is second square 2x times 2. Right. But here you only have this, so you don't want this 2. So what you can do is you multiply half on both sides. Right. So here you remove 2. Here you multiply half. So this part's antiderivative, it's half. Okay, it's half tangent 2x. And what about this part? Right, this part, so notice that cosine 3x plus 5, the derivative, it's negative sine. Right, it's negative sine 3x plus 5 times 3. Right, so now you don't want this 3, right? But you want this negative sign because here you also have a negative sign. So you multiply 1 over 3 on both sides. You multiply 1 over 3 on both sides. So these parts, the derivative is cosine 1 over 3 cosine 3x plus 5. Okay, then the last part we have to plus a constant c. Why? Because for any constant, right, for any constant the derivative is 0, right? So for any constant the derivative is 0. So if you differentiate this, you'll get 0, so it doesn't matter. So for the general antiderivative we have to plus c here. Okay. Then part B, 1 minus x square plus 1 over 1 plus 3x. Okay. First, for this part, you can expand it. It's x to the power 4 minus this plus 1, right, plus this. So for this part, what function's derivative is x to the power 4? So x to the power 5, the derivative is 5x to the power 4, right? But you don't want this 5, so you have to multiply 1 over 5 in front. Okay. So similarly, this part, x squared, right? X cubed, the derivative is 3x squared, right? You want this 3 to be 2, then you have to multiply 2 over 3. And you want a negative sign, you have to multiply negative sign. Right? And this part 1, so x derivative is 1. Right? And this part ln x, the derivative is 1 over x. Right? So it's ln 3x plus 1. But if you differentiate ln 3x plus 1, you'll get 3 over 3x plus 1. You don't want this 3, right? So you multiply 1 over 3 in front. And okay. And it's another problem is here x could be any value, right? X could be, this could be negative, but ln something, you want it to be positive only. So okay, so if you integrate 1 over x, you have to make sure it's ln absolute value of x. Right? If you integrate 1 over x, it's ln absolute value of x. And the last part, don't forget about the constant c. Okay. In part C, the integration of e to the power of 2x okay, first e to the power of 2x. E to the power of 2x derivative is 2e to the power of 2x, right? then you want the derivative to be this, then for here you have to divide by 2, right? And this part, sine inverse derivative is exactly 1 over square root of 1 minus x squared, right? So you integrate this, the result is sine inverse. And this part, tangent inverse, the derivative is exactly 1 over 1 plus x squared, right? So this part you minus tangent inverse x, and then you plus c.